Alright, so I think I'll go ahead and get started. Thanks for coming today, guys. What I'll be talking about today is stone tools. Do any of you guys know when the earliest stone tools appear in the archaeological records? Wasn't it in your textbook? It was definitely Paleolithic, yep. Lower Paleolithic begins with the invention of stone tools. And it was about 3.3 million years ago as of last year. They discovered some a new discovery in Africa. Puts the earliest stone tools back about 3.5 million years. Now, what I'll do is demonstrate how stone tools were made, talk a little bit about fracture mechanics, and discuss some of the finer points of stone tool technology. Now, stone tools are very sharp, so I'm going to put on a bit of safety gear here before I get started. And I'll begin just by making a whole bunch of flakes, and you guys can kind of just watch the process, how it works, and then I'll talk you through exactly what I'm doing in a moment. Okay, so what I'm going to do is go around the perimeter of this stone, knocking off flakes. Now, the edges of these flakes are incredibly sharp, and our ancestors relied on stone tools to adapt to the environment for about 3 million years. Now, while I'm doing this, I will pass around this artifact. This is a chopping tool, or what we call a core, from Africa, and it's at least 500,000 years old. It could be much older than that. It was found on the surface in the desert, and you can feel the edges and stuff. They're very worn from being polished by sand over the eons. But this was a very early stone tool, and it's the sort of thing that I'm making right now. So I'll go ahead and pass that around, and you guys can have a look. It's probably the oldest artifact that you've ever had a chance to examine.
Along those lines, there was a good question on Moodle that maybe you can talk about. And when somebody asked whether the methods and the stones that were used 2 million years ago are the same as what would have still been used 100 years ago. So how much technology has changed with stones?
Okay, we've got a question that was on the Moodle site about how much technology has changed from those earliest stone tools 3 million years ago to ones that were made in the relatively recent past. And I'll be touching on that off and on over the course of the lecture. And the answer is a lot in some cases, but in other cases not so much. And I'll be explaining that here as we go along. Now, the key part of making stone tools has to do with what we call fracture mechanics. Okay, just bashing away at a rock at any location on it, you're not going to get really good results. To get really nice flakes to come off like these ones I'm producing here, you have to know how stone breaks, what the mechanics are of fracture. All right? Now, there's a number of variables involved in fracture mechanics. One of the key ones is you have to have the proper type of stone. Now, not just any type of stone will work to make these stone tools. In order to get off nice flakes like these, you have to have stone that has no grain in it, okay? It can't have any fracture lines or flaws or anything of that sort. It has to be pure inside. You also want to have stone that has a lot of silica content in it. Okay, if you have a stone that's really rough, like granite, lots of crystals and things in there, doesn't have that nice smooth fracture that you need to get nice sharp edge stone tools. Okay, so that's one of the key aspects of stone tool making, and that's one of the trickiest things for us here in Armidale to organize for students to have a go is actually finding stone locally that's suitable for breaking into tools like this. Okay, so that's the first thing, is stone. You don't want any grain or cracks or flaws in it. Another aspect, when I have a big piece of stone that looks like it's suitable for making tools, this is a piece of silkrete from the Hunter Valley down in New South Wales, from the gravel bars down there. I can't just hit it anywhere. Like, for instance, if I were to hit it right in the center of the stone, it's not going to break. I'm not going to get a nice flake to come off. What you have to do in order to make stone tools is you have to hit near the edge of the stone. Okay? Not near the center, but near the edge. Not only that, but that edge has to be what we call an acute angle. It has to be less than 90 degrees. Now, why is that? This all goes back to those fracture mechanics I was referring to before. If you don't have those attributes, the really nice stone and the acute angles on the edge, you can hit it all you want, you'll just get crushing and shattering. But if I strike behind an acute angle like this, the physics of fracture is such that I can get a flake to come off the underside. Now there's another variable involved as well, and that's that I have to hit the stone behind an area where there's a lump on the adjacent face. If I hit behind an area that's hollow, that there's not a lot of mass, like if I were to hit here and try to get something to come off this face, there's not a lump there, and so the flake would just stall. So those are the key attributes that I'm looking for when I'm making stone tools, and it's exactly these same attributes that our earliest hominin ancestors identified and realized they needed to master before they could get stone tools. Okay. Another aspect of making these stone tools, of course, is the hammerstone. You'll notice that the hammerstones that I'm using are look very different from the stones that I'm actually fracturing. The best hammerstones are volcanic rocks or metamorphosed rocks that are very hard and don't have that tendency to fracture or shatter when I use them. Most of them do eventually anyway. You can see that even though this is a very hard volcanic stone, you can nevertheless see that there's a lot of fracturing and shattering happening on the end here. So what I'm going to do is make a few bigger flakes from this piece of silkrete. Now there's no guarantee about the quality of these stones until I break into them, so let's just see if this is any good or not. There's a lot of cracks on the surface, so it may fracture along those, at least initially. Yeah, it's not the best quality stone in the world. You can see it kind of fractured along some cracks that we could see on the surface, but I'll keep going here. And of course, these pieces that are coming off have extremely sharp edges, which I'll talk about in a minute. Okay, fractured along those cracks. So let's try it right there again. Yeah, that piece, not very good, okay? Now that's kind of an interesting case in point. I mean, this stone, I've fractured it, it broke along all those flaw lines. If I was at a quarry site where the stone outcrops, I would just leave that behind. And that's how we get, at quarry sites and stone sources, we get lots and lots of flakes and debris accumulating. So I'll try this one now. This is a different type of stone. This is what we call mudstone, also from the Hunter Valley. And I'm looking all over for those acute angles to start on, with a bit of high mass behind them. We've got a ridge here, acute angle here, so I'm going to hit it right about there and see how we go. Okay, this piece of stone is much better quality, and you can see that we got a good flake to come off that time. Now, what's that?
It looks like bread. The color of it.
Yeah, it's kind of a soft stone. It's not really highly siliceous like flint.
We figured out why it looks like bread. Because it looks like the toy breads you see when you're kids.
Right.
Oh, it does too.
Like the color of it and the outline.
Okay, we're getting a little bit off track here. I don't know if you can hear that at home, but they think it looks like bread. Okay, so let's get back on track a little bit. Now, the piece that I knocked the flake off of is called a core, okay? And this piece that I've knocked off is called the flake, all right? And the flakes fit back onto cores like that. This is some of the basic archaeological terminology that you'll come across. Okay, the place where I struck it is called the platform. This is the platform surface of my core. I struck it right there, and the flake came off the underside. Okay? So the bit of the platform, that surface that comes away with the flake, we call that the platform surface on the flake. Okay? The underside of the flake is the ventral surface. The top side here, the back side, is the dorsal surface. All right? Now, what it leaves behind when I take that flake off is it leaves a scar on the core. That African core that's going around, if you had a look at it, you'd see lots of scars on that core from knocking flakes off of hundreds of thousands of years ago. Okay? Now, what I'll do next, I should mention as well, this outer surface of the stone is all water rolled from being in the river. We call that cortex. Alright, so that's the cortical surface.
I was just saying this before, when I was a kid, we used to go camping out at Barrington Tops, and when we used to go down to the river, we used to find a lot of rocks like that and chuck them at the boulders in the middle of the river, and we used to shatter off.
Yeah. See, that would be, she was talking about as a kid going camping and throwing rocks down on other rocks to get them to shatter. That would be a very uncontrolled method of flaking.
In the middle of the river, so no one actually got hurt. It was just a kind of fun. Like, I was 9 years old.
Yeah. There's
half my life ago.
there's a bit of evidence for that in the archaeological record, and it's called a block-on-block technique, where you take one block and you smash it down on another one, and so you do see artifacts like that in the archaeological record. But what I'm demonstrating here is a bit more controlled than that. Okay, so what I'm going to do is take off another flake, and I can't take it off in exactly the same spot because I've taken off that ridge. That high mass is now gone. So I have to move the core a little bit and find a new spot to hit. So I'll try it right here next. Okay, I've got another flake to come off. Alright, so here's our core now, and we've got a little piece of the flake scar from that first flake, and now most of the face is covered by this flake. But what's interesting is this is kind of how we read this stuff as archaeologists. This first flake, you can see the whole dorsal surface was entirely cortex, but the next flake, we had half the flake scar from the previous flake covering the dorsal surface. Okay, so if I was to find that in the archaeological record, you could kind of figure out, oh, well, this was the second one in a series that was taken off. The first blow was here, second blow here. Okay, so the platform surface, remember the platform where I struck? Fit it back together there. It's still cortical, it's still covered in cortex. So the platforms on both of these flakes are what we call cortical platforms. All right? And those flakes would make great blanks for making more tools. Now what I'm going to do is I'm going to rotate my core now. I could hit it there again, but instead I'll rotate it and I'll hit it here on this surface and see if I can't get some of that ridge to come off. Support it in the sand here. Okay. We got the flake to travel right all the way down that ridge, but as it happens, two flakes came off, which occasionally happens, and that's because my hammerstone stayed in contact with the platform a little bit longer than it needed to. But you can see that's our third flake to come off, okay, and it's run right down that ridge on the face of the core, just like I predicted that it would, okay. But what's interesting now is if you think about the platform on this flake, it's the negative scar from this flake. Okay, let me just put our core back together now. So I knocked off this flake originally, and that created the surface there on the core to knock off this flake. Now we're getting quite an interesting conjoined set, we call these in archaeology, where you can fit the flakes back together and see precisely the flaking that was done to produce this. Now if some of these flakes were missing, you still could take this flake and infer it was struck from another negative flake scar because the platform is different. But you think about the dorsal surface, it's still all covered in cortex. Alright? The reason I'm going into this in some detail is these are the sort of attributes we look at as archaeologists to try to reconstruct flaking technology and how stone tools were made in the past. Okay, so now I'm going to rotate it around. I'll get off a much smaller flake, but again, I'm going to hit it on this negative scar. So that platform then will be a single facet platform. Okay, it'll be that scar from our previous flake. Now look at this edge that's developing. We're getting an edge here that's been flaked to both sides. We call that a bifacial edge. Okay, bi for two, bifacial. And that bifacial edge is very sharp. We've got a lot of mass behind this stone. If you wanted to use that as some sort of chopping tool, it would be absolutely fantastic because you wouldn't have to swing it very hard, just let the weight of the stone do it. And we're getting a nice brutally sharp edge around the outside of this particular block. And if you think about it, here's our African one again. It's almost identical bifacial edge. So we can infer that the hominins that were making this tool, Homo erectus more than likely, was doing that same flaking, going to that side, to this side, to this side, to create that bifacial edge. All right? And we can also think about the flakes that might have come off of this. We would know that, for instance, this flake was struck from this scar, so that this flake would have a single facet platform, and it looks like it undercut some of the cortex, so it would have a bit of cortex on the back. So when we're out and we're looking at flakes out on the archaeological record, those are some of the cues that we can look at to figure out what was going on. So now that you have a little bit more knowledge, I'll pass this around again and have a look at the flake scars, look at where they're coming from, and look at how they reduce down that edge. Okay? All right. Should I keep going with this one? What time we got? I'll go for a little while longer. Now what I'm going to do is stop talking so much and just continue reducing down this core. Get off some nice big flakes, hopefully.
When these shards are set off, they're sharper than surgical steel, is that correct?
They can be. The question was whether these flakes are sharper than surgical steel. This particular stone, probably not. This is a fairly chalky stone, being mudstone. But obsidian, which is volcanic glass, got a piece of it here. Obsidian, flakes that come off of obsidian are in fact the sharpest natural substance known to man, and it can fracture down to 1 molecule edge thickness. It's essentially glass. Glass will be just as sharp. And they do use obsidian in eye surgery. They make blades and use it in eye surgery, although I understand a lot of that's been replaced now with lasers. So what I'll do is I'll pass this around. You guys can have a look, but be extremely careful. It is very sharp. Okay. So you can see getting quite a nice pile of flakes developing. I'm actually going to hold it up high. Get that flake to come off the underside. Choose a different hammerstone. That one fractured. Broke again. It's a little bit better. Okay, so now look at our core. We've got a bifacial edge all the way around. We call this pattern of reduction, where I've come in from different parts of the perimeter, a centripetal pattern of reduction. So you'll see that a lot in the literature, a centripetally reduced bifacial core. It's a bit of a mouthful. Very common in the very earliest archaeological record. Okay, now look at all the flakes that have come off. All right, we've got huge number of flakes, or very large flakes I should say. All these came off this one piece of stone. As it happens, this piece of stone, unlike our first one, which totally shattered, this one didn't have any flaws or any particular problems with the quality of the stone. So each one of these flakes has very sharp edges, and I'll talk a little bit more about what people in the past might have done with these flakes in a minute. For now though, I'm going to continue reducing down this core and see how many more flakes I can get off of it. Okay, now that flake was one of the first ones. I think we might have had one other. No cortex on it, okay? No cortex on the platform because I struck on a negative scar. No cortex on the dorsal surface. All the patterning and ridges on this dorsal surface are from previous flake scars. And we can look at the orientation of those flake scars, we can look at the type of platform that's on there, and we can really reconstruct a lot about how this particular core was reduced, even if we don't have the core. We may not find the core in the archaeological record, we may just find the flakes. Okay, what I'm going to do now is I'm going to start shaping my core. And I'm not worried so much about getting off really large flakes. What I'm making now is what we call, okay guys, pay attention. What I'm making now is what's called an Acheulean hand axe. Okay, that first method of reduction that I demonstrated was some of the earliest stone tools that we have in the archaeological record looked a lot like those. But then, about 700,000 years ago, you start seeing what we call Acheulean hand axes in the archaeological record. Okay, and they might have been discussed in your text.
Yeah, they haven't.
Now think about the flakes I'm making now. Lots of little trimming flakes. I'm less worried about getting off really large flakes because instead of focusing on flakes, I'm focusing on shaping my core into a hand axe. Just using a hammerstone, going around, knocking off these little trimming flakes because I'm more worried about the shape of the object that I'm producing rather than the flakes that are coming off. And look at the little archaeological assemblage that I'm making. Okay, we've got all these really huge flakes from the early reduction of this core. Now we're getting all these little tiny trimming flakes, little biface. Some of them are what we call biface thinning flakes. A few have cortex on them as it slowly gets eliminated from the surfaces. Some of them, especially ones from this face, don't have any cortex on them. So an archaeologist who's trained at lithic technology would be able to come in, look at these flakes, and kind of have some pretty good idea of what was being produced there. Okay, so there's another flake with a cortical platform. Now I'm doing all this with a hammerstone. Some of the later hand axes, around 250,000 years ago, they would switch to a piece of bone or antler to strike another series of thinning flakes off. But I'm replicating more the earlier style, a Acheulean sort of hand axe. Now what's the point of this? Hand axes are a source of enduring mystery to archaeologists. They were made in their millions, and a lot of them were discarded without any obvious sign that they were used for much. Some people have suggested that the importance of the hand axe was not so much as a tool, but it was actually more like a peacock's tail, where somebody who could make these hand axes were showing their reproductive fitness amongst these Homo erectus groups. And so the point wasn't to make a tool, the point was to show that you were effective at making them.
Biologically, the ones that made the superior hand axes are the ones that reproduced.
Exactly, that's the theory. It's very controversial, as you might imagine. Okay, so we've got an earlier style hand axe. You can see these thinning flakes. I should have paid more attention. I could fit them back on maybe, but I didn't pay attention to where they were falling. But anyway, we've got lots of thinning scars on here. We still got a little piece of cortex, and we've got a bifacial edge carefully trimmed around the whole perimeter. Classic Acheulean hand axe. And if anybody is particularly interested, I can show you some real examples. If you come to my office sometime, I can dig out a couple and show them to you. Okay, now what I'm going to do is something entirely different, and that's, well, a different way of removing flakes. Now you've been seeing me use a hammerstone, and when I used the hammerstone, it was probably most notable on these really big flakes. I was striking in from the edge a little ways. I wasn't hitting right directly on the edge. I actually would hit, deliver the blow in from the edge. Now what I'm going to do is I'm going to strike directly on this edge. I can't use a hammerstone for that because a hammerstone would just crush the edge. So what I'm going to do is I'm going to get rid of the sharpness of the edge by grinding it a bit. And I'm going to use one of these. This is a piece of antler. In this case, this is moose antler. A bone would work. And I'm going to hit directly on the edge. Now, you wouldn't think that bone would be able to break stone, but what happens is that edge bites into the bone a little bit. You can see that it's getting this wear facet on there, and it prolongs the contact. It doesn't crush the edge because the stone is actually biting into the bone, and then I'm able to get a flake to come off the underside. So what I'm going to try to do is, you've got that mass. It's still the same principles. It's an acute angle, got the platform surface there, and I'm going to try to strike the flake along that zone of high mass. Okay? So, okay, there's my flake. I've struck right on the edge, and it's traveled, it's got a lot of gooberage in there, technical term, little fractures and stuff. Got stalled a little bit in the gooberage. But you can see my flake took a little bit of that patch of cortex off, so we're still getting a little bit of cortex on the flakes, but the platform is very different, okay? That area that I ground, you can feel that with your finger. It came away with the flake. So when we see something like that in the archaeological record, which we don't see till about 250,000 years ago at the earliest, very, very profound change in technology, because you think about it, now instead of just using stones to make stones, some hominin in the past got the bright idea of using bone to fracture the stone. There we got almost all the cortex to come off. That flake went past the center line all the way to there. So now I'm going to do the same thing over here. Grind that edge. And we'll give it another whack. Okay, that went all the way to there. That one went all the way to there. Now, what the soft hammer flaking does for you is allows you to strike flakes that travel past the center line of the biface, okay? So, and we got the last little bit of cortex off now. Okay, so now I'm gonna pop one down that ridge, like that. Now we're getting these small trimming flakes, these little biface thinning flakes. Almost no platform on them at all, but if you feel it with your finger, you can feel where I ground that edge a little bit. So think about how far we've come in the 20 minutes that I've been talking. You know, from this very early stage reduction, our very earliest flake with the cortical platform on there, to a little bit later flakes that I was setting up on the negative scars from previous flakes. We had these single facet platforms, really big, thick, clunky flakes, and we've now shaped them, gone into the shaping phase and thinning phase, and producing these little biface thinning flakes, okay? And we've got an Acheulean hand axe developing, all right? So I could tinker around with this for a while, but I won't do that. Instead, I'll just pass it around. You can have a look. This is a sort of a classic tool from the later Acheulean, and the assumption is that people were using them to butcher meat in particular. We already talked about the idea of sexual selection in biface manufacture. There's one really interesting study out there that's a little bit bizarre, but it's kind of fun anyway, where some guy reckoned that most hand axes were found around water holes. So he reckoned that they were throwing them like frisbees to try to either get game to run and trample each other to death as they stampeded out of the way of these flying hand axes. Because if you actually got struck by one of these, it probably wouldn't do that much damage. You would hurt a bit, but I doubt if it'd bring down an animal. But that's one of the more outlandish suggestions. And I think the consensus is that these are probably some sort of butchering tool. Now, I haven't talked much about cognition. One of my particular research interests is the evolution of modern human cognition. And that by that I mean just the way that people think. Stone tools are, we've got a fantastic archaeological record of stone tools going back 3.3 million years. And of course, people like us, humans, modern humans, weren't around back then, okay? But, so what we've got is a continuous record of stone tool manufacture by all our hominin relatives over the course of evolution. And so, since we have that continuous record, because stone is very pervasive in the archaeological record, you can't destroy it once this stuff is, once these artifacts are made. This will be around for potentially hundreds of thousands of years now. We've got a great database for tracking the evolution of abilities, of stoneworking abilities, which in themselves might be a measure of changes in the developing cognition of hominins. People have suggested in the past that even right down to the morphology of our hands might have a lot to do with stone tool manufacture. I've had my Michael Jackson glove on there, but if you could have watched my hand, lots of movements in holding the core, yeah?
I just wondered, I noticed you're using your right hand to do all the hammering.
Mm-hmm.
If someone was using their left, would that change the shape, or it would end up with the final same in the end?
Now that's really good question. People have tried to look at stone tools and look at, the question was, for you, those of you at home, if you couldn't hear, was about handedness, whether if I was left-handed, if it would change the characteristics of the stuff that I'm producing. Archaeologists have looked at that because trying to figure out handedness and the development of handedness amongst our hominin ancestors has been of particular interest to physical anthropologists. And so they've come up with different ideas of how you might get at that. Now I can say that a left-handed modern human napper and a right-handed modern human napper are equally capable of producing stone tools. I'll pass the hand axe around while I'm talking about this. But one archaeologist out there has suggested that the ways that cores were rotated as reduction proceeds has an influence on the distribution of cortex on the flakes, depending on if you're a right or left-handed napper. Now I'm right-handed, and I'll just show you briefly what I mean. If I knock off all the flakes from this core unifacially, I rotate it. My tendency as a right-handed person is to rotate it like this, knock off the next flake, rotate it like this, knock off the next flake, rotate it like this, knock off the next flake, and then just continue around the perimeter of the core, knocking off these flakes in this fashion. Now a left-handed napper, I can't do it because I'm not left-handed, but they would rotate their core in the opposite direction. So instead of rotating it like this, they would rotate it like this because they're left-handed. Now if you think about the cortex, that flake right there, that early flake, my first flake I took off here like that, and then I rotated it like this because I'm a right-handed napper. The cortex winds up on that side of the flake. If I was a left-handed napper and went the opposite direction, the cortex would be on this side of the flake and the scar would be on that side. So an archaeologist went and looked at some of the earliest archaeological assemblages in Africa, and he recorded on these little flakes, very meticulously recorded which side the cortex was on, and he argued that based on that evidence the nappers were predominantly right-handed. This is going back to the old Awana assemblages well over 1 million years ago, closer to 2 million years ago. So that's the kind of evidence. I mean, that's the way you think as an archaeologist. Okay, that's what I want to study, is right and left-handedness. We've got all these beautiful stone tools from the archaeological record. What is it in the stone tools that I could look at to get at that? And that's one idea that's been put forth. Okay, so now I've already started on reducing down one of the flakes from one of our large flakes from earlier in reduction. Now what you tend to find in the archaeological record, particularly in Australia, but other parts of the world as well, is that people at quarries would produce big flakes like this, and they'd take these big flakes away with them. They might look at something like that and, oh, you know, that's all the thin stuff, I'll get rid of that. This is all happening at the quarry where they've made their big stone tool, They're trimming away the stuff that they don't think will be any good because they don't want to carry all that excess weight. So trimming all that away, but not too much because you want to leave some mass left in the stone. And then that gets carried away. In Australia, the Aborigines put that in their dilly bag, go across the countryside. They could use this cutting edge on here for all kinds of heavy woodworking tasks, you know, cutting bone or cutting wood or whatever. These sort of edges work really well for that. Or they could do what you saw me do here. I knocked off these 3 flakes from this core. This is again one of our big flakes. I can get lots and lots of flakes from a core like this. So if I went out and I killed a kangaroo or a deer, I could just strike one of these flakes off when it became time to butcher it, and that edge would be absolutely razor sharp because you just created it. Had a couple split on me there. Okay, so look at the series of flakes that I'm getting off here. That one's stuffed up a bit. Trim that back. That one's split. And this is really typical of what we find in the archaeological record. Lots of flakes like these. And look how productive this one flake has been. How many flakes I've been able to get off. And don't let the size fool you either, because these tiny little flakes are very, very useful. Sometimes these big flakes are for doing delicate jobs. Not that great because they're just too big. You want a little tiny flake if you're doing some delicate carving on a handle or whatever. So little flakes are very useful, just as useful as big ones, in fact more so in some cases. Okay, so think about how productive this little core has been. Okay, so it's starting to step and hinge out a little bit there, so I'll stop. So in the archaeological record, got all these flakes that came off of this core, you know, and that's quite a few flakes there. There's at least 15 or 20 there, good flakes. And we've got the core. I started stuffing it up a bit, stepping it out, so I might throw that away. These flakes might be left in the archaeological record where they were struck and used. Like if I needed to butcher a kangaroo, would have struck off that flake, used it. It might have got dull or all matted up with fur or whatever. Chuck it away. You've got another one of these in your toolkit. So it's just a great way of making these little expendable knives. We call them expedient tools because you're making these little expedient knives, using them for different tasks, throwing them away. And just to give you an idea, over the course of about 3.3 million years of evolution, I did some back-of-the-envelope calculations and estimated that for all the habitable land on Earth, there'd be about 1 flake for every 2 square meters, just based on certain population sizes and how many tools people might use in a year. That's how plentiful this stuff is. And just to give you an idea, one of our students who I trained in recognizing flakes and stuff, just coming behind CO2 along that slope, there was a silkcrete flake. Aborigines were on top of this hill over there. There's silkcrete flakes. There's a silkcrete quarry on the little knoll just over the other side of Clark's Road. You guys have probably driven by it every day if you drive into the uni. That's a silkcrete quarry. There's little Aboriginal campsites. And the reason we know this is because we can find these flakes because they're so durable in the archaeological record. Things like bones and stuff are a little bit trickier because they tend to disappear, but stone tools are forever. All right? Back to that early question about that was on the Moodle site. Now think about the technology that I've done here. I've gone from Oldowan, some of the earliest stone tools, just that simple radial core, to Acheulean, the hand axe, with that bifacial flaking. Now, and then I went back and I'd actually demonstrated the way that Aborigines might have approached stone tool making, some basic aspects, from one of the flakes that I produced in demonstrating the Oldowan core. So there are themes that run through all of stone technology, where you have some of the very earliest stone technologies tend to be used right up into the recent past. But what people did is the more complex technologies would be added on top of that. So as their basic toolkit, they'd have a lot of this sort of stuff going on, even right down into the Metal Ages, the Copper Age, the Bronze Age. You find lots of stone tools like that because they're still very useful. But particularly in the Neolithic and some of the later hunter-gatherer groups in Australia and North America, they started doing some very elaborate stoneworking that involves this basic bifacial method of reducing stone. And I don't have time to demonstrate that now because sometimes making a stone point can take, some of the big Danish daggers and stuff would take upwards of 30 or 40 hours to make some of the really long stone daggers. This is a stone point that I made in the North American style, and it probably would have taken about 20 minutes or so to make that. I've put notches in it using a technique that I'll demonstrate here in a second to put those notches in there, and then I tied it on with sinew. Needs a little bit of high glue on there to really tighten it up, but I'll pass that around to show you some of the fancier results of stone flaking that you get with modern humans in later prehistory. Okay? So what I will do is demonstrate a little bit of what we call pressure flaking. Now what I've got over here is a knife, a little bifacial knife. If you think about the little hand axe I made earlier, it's flaked bifacially to create that edge around the outside in a piece of Australian silkcrete. This was a little knife I carried around at the recent experimental archaeology intensive school, and I used that edge for a lot of different cutting tasks and stuff. And you can see there's some residue on that stone tool from shaving wood or something in that area. But what I'm going to do is I'm going to resharpen it by what we call pressure flaking, which is an entirely different sort of technique that arose around 20,000 years ago. Now what pressure flaking entails, get my tools ready here, tilt that down a little bit, is pressing against the edge of the stone with a piece of bone. Now I've already talked about how bone for percussion flaking tools is really good because the bone bites into the edge and you can get a really long contact period and get really good flakes to come off. But you can also use bone for what's called pressure flaking. Now what I'm going to do is I've got this piece of deer antler here, and I'm going to put the tip of the deer antler against this bifacial edge, and I'm going to push in and then down, and a little flake's going to come off the underside. Okay, there's my tiny little flake. It ran all the way to there, and it's an itty bitty little flake, but that's okay. I'm going to throw the flake away because what I'm interested in is producing a really sharp edge. So now I'm going to move up a little bit, take off another one, another one, another one, another one. And what that's done is it's created a really keen edge on the edge of the tool. Now not only can I produce really sharp edges by this pressure flaking technique, but you can also get really nice patterns in your flaking, like a little ripple shaped flake scars, which are aesthetically pleasing. So what you tend to find in later prehistory is a lot more attention paid to the aesthetics of pressure flaking, not only to get the shape of the stone tool they wanted, but also to develop those faces of the stone tool in sort of an aesthetically pleasing manner by taking off these little pressure flakes. If you go out on sites in certain parts of the world where there's a lot of pressure flaking going on, like in the Kimberley in Australia or all across North America, you find pressure flakes in their hundreds of thousands on campsites. All these little flakes everywhere. Now I don't know if this will show up to those of you at home, but you can see the patterning of the flake scars along here, all parallel. That's some of that fancy pressure flaking results that you can get just by taking off these little series of pressure flakes, one after another down the edge, and it creates an incredibly sharp edge. So I'll pass that around. You can have a look at the pressure flaking on that. Okay. Clovis point. Now Clovis point is sort of like that, where it's bifacially flaked, flaked on both sides. Here's a bifacial blank here, made from stone from Western Australia. But what they do for Clovis technology is they would flake the biface from both sides to create a ridge right down this face, right down the face of the stone. And then one of the very last steps of Clovis technology was to prepare a platform. You guys know what platforms are now. Prepare a platform down here at this end, grind it very carefully, hold the point. You have to support the tip, hold the point like that, strike the platform to get one long percussion flake to come up the center of the face of the Clovis point. Okay, so they do that on one side, and if it didn't break, they'd re-prepare the platform by pressure flaking again, prepare that platform to take a flake off the opposite face, flip it over, boom, take another big long channel flake off the opposite face. Extremely risky. It's very difficult to do without breaking the blank in half. Some people, and you can see this from some of the Clovis points themselves, think it was done by indirect percussion, which I haven't really talked about today, but that's where you would take a punch, because you can get that punch onto the platform at exactly the angle you want. So you'd put that punch on the platform like that, and you'd hit the end of the punch to get that flake to come off. So yeah, that's a very Clovis point technology is pretty advanced stuff, done by the first colonizers of North America about 14,000 years ago. Any other we got about 5 minutes for questions if anybody's. Everything you wanted to know about stone tools, but were afraid to ask. All right.
Point out that Mark makes it look very easy too. As a student,
No, it doesn't.
Does somebody want to volunteer? Anybody want to volunteer? I have some gloves and some safety glasses. Do you want to have a go?
have a go.
Anyone?
You should have a go. It really, it's
All right, we've got a volunteer.
Only so we can test the left-handed thing.
You left-handed?
I just don't want to embarrass myself. This sitting there, poking, knocking, tapping.
You'll get your chance.
Once it was horrible. But one thing you find is that a sharp edge will cut even if it looks flat.
It looks like fun. I want to go.
Have a go. Have a go.
Yeah, try it. I need someone else to embarrass myself with.
I have a feeling the stone.
Oh, you need a hammerstone. Hang on a second, I'll get you one.
Fortune favors the brave.
That's why he told you to put safety glasses on. Yeah, maybe.
So, what about around there somewhere?
Oh, look for the acute angle. Show me your acute angle.
There's one there.
Okay, what face is the flake going to come off on?
My knees don't like being.
Do you want me to give you some hints?
Sure.
You got a good acute angle right there.
Yeah.
Okay, and you've got a zone of mass there. So what you want to do is you want to hit it right there on that apex and see if you can get a flake to travel along there.
So, if I hit around there.
Got to give it a good crack.
My foot was numb half the time. That's why I had to like running it.
A little bit to come off. You got to hit a little bit further in, I think. Give it a good crack.
Yeah, that'd be me.
All right. Well, go ahead. Keep going. I'm just going to sign off to the people at home.
Oh, nice.
Oh, this is painful to watch. We'll just